Hi class, this is Mr. Morris. I just wanted to go through an introduction to the new unit called Solutions. So let's get started. First of all, let's define what a solution is. A solution is a homogeneous mixture. Now we've talked about that in the fall, so this part is review. But what does homogeneous mean? Let's try to refresh ourselves on that. Homogeneous is talking about the appearance of the mixture. It's a mixture that has a uniform appearance. That means it looks the same throughout it. So if you were just looking at it, it would appear that it's the same substance. There's no difference throughout the mixture. But we know that at the molecular level, they're separate. So it's a mixture of two or more different substances, two or more different elements or compounds. But if you're just looking at a mixture of it, it looks the same throughout. In a solution, one or more substances dissolve in another substance. So that's an important thing to recognize, this word dissolve. So let's talk about the parts of a solution. A solvent. The solvent is one part of a solution. The substance that does the dissolving, it's usually the greater amount. This is the substance that the other one dissolves in. Solute is the substance which is dissolved by the solvent. It's the one that you put in the solvent and it dissolves in the solvent. And then we have the solution. Now the solution is what the mixture is after the dissolving is complete. After you've put the components together, stirred it up, and it's mixed completely, that is a solution. So here's a sentence that kind of sums it all up. The solute dissolves in the solvent to form a solution. So hopefully that makes sense. The solute is what dissolves in the solvent, and in the end, it makes a solution. Let's do an example here real quick. Sugar water. Now some of you have already made sugar water before in your life, so you probably have seen this. This may be nothing new to most of you, but let's just go through it real quick. So I've got some water sitting here in a cup, and I've got some sugar here in a sugar bowl. Take a spoonful of this sugar and I put it in. Now if you look at it after I put it in, you can still see the sugar crystals floating at the bottom. But if I stir it up for long enough, it almost looks like it disappears. Now you know that it didn't actually disappear, but as I stir that up, what happened is those water molecules surrounded the sugar molecules so that it dissolved. It dissolved in the solution. Now let's look at a molecular view of this and see what's actually happening at the molecular level. So this first picture is kind of what it would look like when the sugar was first settled on the bottom. Now, those of you who are a little bit ahead of me, these are not sugar molecules. Sugar molecules are a lot more complex than this, but for the simplicity of this picture, I wanted to pick something that would look a little more simple. So we've got these water molecules floating around. That's our solvent. And then we've got a solute sitting at the bottom. It hasn't dissolved yet. It's just sitting at the bottom. But if I were to stir this up, what happens is those water molecules are going to break up the clump and surround the individual molecules of my solvent, of my solute. So if we look at the next picture, that's what we have here. See, these water molecules have broken apart the clump so that there are no two molecules of the solute that are clumped together. They're separated and surrounded by the water molecules, and that's what dissolving actually looks like. The molecules of the solute are surrounded by the molecules of the solvent, and it pulls it out into this solution. That's why it looks the same throughout. So going back to our example of sugar water, our solvent was water, our solute was sugar, and the solution was sugar water when we were done. All right, we've got another example here, coffee. See if you can figure out what's the solvent, the solute, and the solution. Okay, the water is the solvent, the coffee grounds, the soluble parts of the coffee grounds are the solute, and then you've got your solution that is made, which is coffee. And then another example would be tea, very similar to coffee, how you make it. You've got hot water that you put the tea leaves in, and there's some soluble components in tea leaves that dissolve in the water, and then you might mix in some sweetener of some sort. So what's our solvent? And what's the solute? Solvent's water, and your solute is going to be tea leaves, sugar or honey, whatever you put in your tea. Kool-Aid. Kool-Aid is made, of course, by mixing the Kool-Aid mix and maybe some sugar in with the water. What's our solvent? Again, it's water, and the solute would be Kool-Aid mix, and possibly some sugar if you buy the mix that doesn't have the sugar already in it. All right, air. Now this one might throw you off a little bit. It might seem kind of weird because air, that's not a liquid. Well, the thing is, solutions can be anything. They can be solid, liquid, or gas. They can be in a lot of different states of matter. So the air that we breathe in, if you're in a healthy environment, pure air is actually not just one substance. It's a lot of different things. It's about 78% nitrogen, 21% oxygen, and 1% argon. There's a lot of other components that are in the air, but they're less than 1%. So we're not going to talk about those right now for simplicity. What's our solvent? I hope you said it's nitrogen. It's the largest amount is nitrogen, so that's our solvent. Our solute would be oxygen, argon, and any other gases that you put in the mixture. Sterling silver. So if you've ever gone to a jewelry store to buy some inexpensive jewelry, you've probably seen this word. Sterling silver is an alloy. That is a solution. It's a homogeneous mixture of metals, of solid metals. So they melt these metals down and they mix them together, and then as they harden, you've got a alloy. This is about 92% silver, so it is mostly silver, and 7.5% copper. What's the solvent? It's silver, and the solute is copper. Of course, our solution would be sterling silver. Some other really important terms you need to know. Soluble. Soluble means it's able to dissolve in a given substance. We don't usually just use the word soluble by itself. You'll hear the word water soluble. That means soluble in water. If it's water soluble, it means it will dissolve in water. Okay? Or we might say it's soluble in oil, in olive oil, whatever. Insoluble is the opposite of soluble. It means it's unable to dissolve in the given substance. Again, it's water insoluble. It's insoluble in water, insoluble in oil. So here's an example. Sugar is soluble in water, but it is insoluble in oil. So it will dissolve in water, it won't dissolve in oil. A couple other terms, and then we're going to be done. Miscible. It's just like soluble. There's only one difference. Miscible means we're mixing two liquids. So this is specific to the state of matter liquid. Miscible means that when you're mixing two liquids together, they are soluble. They will dissolve in each other. If two liquids are miscible, they will dissolve in each other. Immiscible is the opposite of miscible, and it means if the two liquids are mixed, they won't dissolve in each other. They're immiscible. So miscible, there's a lot of things that are miscible. You could say vinegar and water. If you mix vinegar and water together, you'd find that they would dissolve. Alcohol and water, mix them together and stir them up, they're going to dissolve. They're miscible. Immiscible, the most common example you've probably heard is water and oil. Water and oil are immiscible. They won't mix. So if you were to take, and you could do this, you could take some water and take some olive oil, and pour them together, and just watch them separate into two different layers. They're immiscible. I hope this was helpful. Hope it made sense to you. And we're going to be talking a lot more about solutions as we kick off this unit.